This video is going to go over one problem on the review sheet for Chapter 4A. We're going to look at number 5, sketch a probable graph of this. This is because this question is a little bit more difficult than it might look. So, I know right away that we have 1 as a root, -3 as a double root, and -1 as a triple root. There's meaning behind that, and it's more complicated than just kind of putting them all there. So, let's turn on the grid, and let's go over and kind of graph some of this. So, I'm going to pop over here. We've got roots are -1 is a triple root, -3 is a double root, and 1 is a root. Well, what I can tell about this is also a degree of 6 for two reasons. There are 6 roots if we count multiplicities, and if we look at all the powers here and try to multiply that all out, we get an x to the 6th. We also have positive coefficients, so my n behavior, if I can spell that right, is something along the lines of this, which means the graph is going to do something like that. Some other things I can tell would be, I know that if it's degree 6, there are either 5, 3, or 1 turning point. We'll get to that and use that as a check. That's my turning points. Something else I can check out would be looking at my y-intercept. Y-intercepts occur whenever you plug 0 in for x. So if I plug 0 in for x, I get -1 times 3 squared times 1 cubed. Well, that would be -9. So my y-intercept is actually down at -9. Well, that's pretty far down, but I suppose I can reach all the way down there. Okay, here we are at -9, but let's kind of work our way back up. And -9 doesn't necessarily have to have any sort of special meaning behind it, in terms of our turning points and stuff. Okay, let's go back to the root analysis. I know that 1 is a root, but let's start from left to right. We're kind of coming in from up top, and then it says this is going to be a double root. Well, double roots are turning points. And if I come down from top and I hit that, I have to jump right back up. Okay, one other check we can do would be our sign graph. If I created a sign analysis and did -3, -1, and 1, and I test my regions, well, if I test -4, for example, I'm going to get a positive region. I have -5, the squared isn't going to matter, and -4 plus 3 cubed is going to give me a negative, and a negative times a negative, should be negative times a negative, that's a positive. So essentially I have a positive here. And if I test like -2 in between -3 and 1, I also get a positive region. So what's happening with the double root is it's coming down and it's turning at the root. It's going to come back up, but we have to go back down instantly again because we're going to hit this point. And this is a triple root. Now, if double roots are turning points, then triple roots are points of inflection. So I'm going to come down, and I'm going to hit this and just kind of squarely, actually I'm going to do this a little better than that. I'm going to hit this and squarely just end right there. Boom. Straight down. And now I'm going to change concavity. So we're going to go concave down. Now, I don't know that -9 is a turning point. It might not be, but it's directly in between -1 and 1, so why not? Let's have it come down. We're going to go all the way down to -9, our y-intercept. Then we're going to come all the way back up. There's nothing special about +1 as a root, and it's not a change in inflection because we don't have any more turning points left, so that just kind of continues up. And that's the sketch of our graph. If I zoom out, here's a pretty good sketch of it.